going to discuss Theorem 1.1 Euclid division lemma, and we're going to see a solved example, and we're going to solve this example ourselves. We're going to see how we can apply this lemma in real life. So it's going to be interesting, and I hope that you pay attention to every single step that I would be showing you here. So example 1 says, use Euclid's algorithm to find the HCF of 4052 and 12576. So, to obtain the HCF of these positive integers, follow the steps below. So basically the question is asking you to use Euclid's algorithm. Don't be confused between algorithm and lemma, it's similar. So let's see the steps of how to find the HCF of these two positive integers. Step number 1. Since 12576 is greater than 4052, we apply the lemma to 12576 and 4052 to get this equation. So here we have 12576 is equal to 4052 into 3 plus 420. So this is the dividend, this is the divisor, this is the quotient, and this is the remainder. Let's see how we are going to solve this question. So moving on, we have step 2. Since the remainder 420 is not 0, we apply the lemma to 4052 as the dividend and 420 as the divisor to get. So here we will have 4052 as the dividend and 420 as the divisor. Because 420 is not equal to 0. If in the earlier step we would have got the remainder as 0, we would have not moved on and we would have not come to step 2. We would have got our answer in that step only. But until the remainder becomes 0, we have to continue. So in step 3, we consider the new divisor 420 and the new remainder 272 and apply the lemma to get 420 is equal to 272 into 1 plus 148. Again, so until and unless we get 0, we are going to continue with this lemma. We're going to keep applying it. We're going to get a new divisor and we're going to take the new remainder and apply the lemma to it. I think you're very familiar with the equation. A is equal to B into Q plus R, and it's not very difficult as you remember, as long as you remember what is dividend, what is divisor, what would be quotient, and what is remainder. So let's move on and see. So we consider the new divisor 272 and the new remainder 148 and apply the lemma to get 272 is equal to 148 into 1 plus 124. As you can see in this step also, we are not getting remainder as 0. So we will consider the new divisor 148 and the new remainder 124 and apply the lemma again. 148 is equal to 124 into 1 plus 24. Since again we got 24 instead of 0, let's apply the lemma again. We consider the new divisor 124 and the new remainder 24 and apply the division lemma to get 124 is equal to 24 into 5 plus 4. You might be thinking that it is a tedious procedure, but it's not so difficult. It's very easy. You just have to keep doing it, keep going on, and don't worry, you'll get the right answer. So as you can see, we have still not got the remainder as 0. So we need to do more steps until we reach the remainder as 0. So we consider the new divisor 24 and the new remainder 4 and apply the division lemma to get 24 is equal to 4 into 6 plus 0. So now here you can see the remainder has now become 0. So our procedure will stop. Now we don't have to do further calculation because our remainder has become 0 and it will make no sense. Since the divisor at this stage is 4, the HCF of 12576 and 4052 is 4. HCF, that is the highest common factor. So the HCF will be 4, and this is how you're going to solve questions using this lemma. It's very easy. It is just the long division process, and we're going to look at how we can have more tricks and how we can see this question in a more different way. Notice that 4 is equal to HCF of 24 and 4, and HCF of 124 and 24 is same, and so on. So as you can see, 4 is the HCF of all these numbers. Yes, these pairs, 4 is the HCF of all of them. This is a very interesting fact here, and you're going to maybe need it in some problems. So I hope that you can see this fact and try to realize that what is happening here, it's nothing. It's just that all these pairs have the same HCF, that is 4. So this problem was not very difficult. It was just little lengthy. That's it. So moving on, I have some remarks for you. You're going to find these very interesting. So first of all, Euclid's division lemma and algorithm are so closely interlinked that people often call former as the division algorithm also. So we have also seen this, that the lemma and the algorithm are actually very similar. They're very same. So if a question mentions lemma or if a question mentions algorithm, I hope that you don't get confused and don't start thinking that what is a lemma or what is algorithm. That is not what we're trying to do here. The basic thing is that we're trying to follow a proper steps, and that is what you need to do. So if the question mentions lemma or algorithm, don't worry about it that much. The second thing which we have is that although Euclid's division algorithm is stated for only positive integers, it can be extended for all integers except 0. That is, b should not be equal to 0. So you can do this and you can get to know about it, you can search about it, but we're not going to discuss it today because this is beyond the scope of our discussion. So for today, we just had one question, and you saw how you can solve it step by step, and I hope that you try this question yourself again and approach it and do it in a step by step manner. And if you get stuck somewhere, try to deal with the problem yourself and then refer to the solution. I hope that this video made that question some clear and you got to know as to how you can use this concept. And thank you so much for watching.